This tall mast on Winterhill is a well-known landmark in the northwest of England. It stands just over 1,000 feet tall on the top of a 1,500-foot hill, so it is noticeable for about 20 miles around. It's located about 5 miles northwest of Bolton, and it is the main TV transmitter for the region, transmitting both BBC and commercial TV programs to a potential audience of about 6.5 million people. My name is Bill Learman. I know Winterhill well. I did 2 tours of duty there for the IBA from 1961 to the end of 1965, and later from 1972 until I retired in 1987. The relief map shows the location well and just about covers the area served by the station, roughly from the Pennines in the east to the Irish Sea in the west, and from Barrow in the north to Buxton in the south. The westward spur of the Pennines is the Rossendale Forest, and Winterhill is on its western extremity. It has a commanding view of the Lancashire Plain and the Cheshire Basin, including the large cities of Manchester and Liverpool, and the populous areas of Cheshire and the Lancashire cotton towns. The geology is of the Carboniferous age, formed about 300 million years ago. The underlying rock is millstone grit, covered by a measure of about 1 metre of coal, then about 15 metres of shale and clay stuff, with 1 or 2 metres of peat on the top. Northwest of Bolton is the town of Horwich, just south of Winterhill, while the valley to the northeast of the station is the site of the village of Belmont. Hampson's History of Horwich of 1883 records the site as being midway between Horwich and Belmont, and on a pack-horse route which was the preferred route to Belmont before the coming of the coach roads, the distance being only 3 miles. And this map shows the 3-mile route with acknowledgements to the internet and Google Earth. The approach is via George's Lane, which is the first road on the left after the Jolly Crofters pub. Continuing up George's Lane past Montcliffe Quarry, the station road is on the right between the houses by Montcliffe House. Expanding the map, the triad of white lines shows the 3 stay lanes of the mast. You see the shadow of the mast going off about the 11 o'clock direction. We have an unfortunate map join near the top of the picture. The upper sheet is considerably darker, and of course the join does not correspond to the line of the Winterhill escarpment. I've tried to indicate the escarpment line with a rather blurry dark line curving around from the north of the site to the northeast and ending in the dots by mast number 7. The slope of the approach road is quite gentle up as far as the ridge. Over the edge the ground falls away very sharply for about 700 feet down to the level of Belmont. On the west side of the station the River Douglas rises in our backyard and makes its way down through Horwich and Wigan before turning north to join the sea in the Ribble estuary near Preston. It is not unusual for map makers and others to set their boundaries on isolated hilltops. The TV mast occupies land in 3 parishes. The northern stay blocks are in the borough of Blackburn with Darwen. The eastern stay blocks are in the borough of Bolton, while the station buildings and the western stay blocks are in the parish of Rivington in the borough of Chorley. So we pay council taxes to 3 councils. Turning now to the history of the site, it begins with the tumulus at the top of the map. It is called the Winterhill Barrow. The next picture is from the Bolton website. There is not much to be seen at the barrow, but it is an interesting piece of archaeology. Briefly, the text reports that the site was excavated in 1958, that it contained pollen which was carbon dated to 1500 BC. The tumulus was considered to be the burial place of an important personage who lived and died in the area. There was also evidence that the site had been excavated about 250 years earlier. Returning to the map, in the 19th century there was a great deal of small-scale coal and clay mining on the hill. Hampson's history mentions a hamlet called Five Houses. At the hamlet there was a dwelling and beer shop owned by a master collier called James Garbrett. Apparently there was evidence of some 85 coal pits on the hill in 1885, also some drift mining. With limited machinery at the site, they sank a pit to the coal 50 feet down, worked it as far as they could to about 100 yards from the foot of the shaft. Then they moved on and sank another shaft further along and worked that. They capped the old shafts with wood planks about 15 feet down and filled the tops with earth. By now the planks are decaying and the hill is pockmarked with collapsing pit shafts. You'll notice these on some of the slides. No history of Winterhill would be complete without the story of the Scotsman's stump. George Henderson was a packman, a travelling salesman who sold goods around the district for a merchant in Blackburn. On the 9th of November 1838, Henderson was walking from the village of Blackrod towards Darwin via Winterhill. He had arranged to meet a colleague, Benjamin Birrell, in Garbrett's beer shop at 11 o'clock. Birrell did not show up, so Henderson continued on his way. He was found by the roadside further up the hill about an hour later. He'd been shot through the head. He apparently said, "I am robbed, I am killed," before expiring. This is the plaque on the Scotsman's stump. The stump is just across the road from the TV station. The first radio stations on the site were installed by Lancashire Constabulary in 1950. They were pioneers in the use of police radio, particularly mobile radio. They upgraded the Packhorse route to a passable vehicle road capable of taking the necessary construction traffic and had an electricity supply brought in from the Belmont side of the hill. Their stations are at Masts 1, 3 and 4. They provide communications for police, fire and ambulance services. Commercial television started in this country with the Television Act of 1954. The ITA and GPO engineering people came on site with the start of ITV in this area in 1956. They brought in a second electricity supply from the Horwich side and made further improvements to the road. Here we have the original TV mast, a self-supporting 450-foot tower, basically a 350-foot chain-home radar transmitter tower with a 100-foot lattice mast on top supporting the transmitter aerials. These gave us 100 kilowatts effective radiated power from a 10 kilowatt transmitter, sufficient to serve the area you saw in the first relief map. After about 6 years, in 1962, we were joined on the site by the BBC with a fill-in transmitter for their BBC One VHF television service to Blackpool and the Fylde area. Pictures were in the 405 line black and white standard, but still a technical challenge with the transmitters of the day, designed before the age of microchips or even effective transistors. The transmitters required much maintenance, frequent readjustment and continuous monitoring. There were about 200 valves in each transmitter, and we usually replaced about 3 valves per day just to maintain an acceptable output picture. This was okay until the coming of colour television. The Stockholm Plan of 1962 decided we would do colour on 625 lines in the PAL system, transmitted in the UHF band on frequencies 4 times as high as we used for black and white. To achieve the same coverage it required higher power, 500 kilowatts ERP in fact. Also the mast height had to be increased to 1,000 feet. The mast is stayed at 5 levels, with 3 stays at each level. The stay tensions range from 9 tons at the top to 30 tons at the lowest 230-foot stay level. The total downthrust of the stays is 250 tons in still air, doubling to 500 tons at the design maximum wind speed of 120 miles per hour. The mast dead weight is about 100 tons, so the base loading fluctuates from 350 tons to a possible maximum about 600 tons. Problem: how to support a load like that on the ground of Winterhill. They constructed a platform like a big kitchen table. The tabletop is 30 foot square and 8 feet thick, with its 4 legs 9 feet in diameter, and stood on the bedrock 55 feet below, all made of high-grade reinforced concrete. The picture shows the excavation for the tabletop and the excavation of one of the leg holes in progress. Finally, a massive cage of reinforcing steel is installed in the leg holes and the platform space, and there follows a few days with a fleet of concrete lorries coming up the hill, pouring concrete non-stop. A few weeks more and we have a nice flat platform carrying the concrete mast plinth structure. 6 pillars of very strong reinforced concrete with a ring beam on top. And here is a breathtaking moment as the steel ring beam, the bottom of the steel mast proper, is introduced to the bolts in the concrete plinth. It fitted beautifully, and I guess the engineers had a bit of a party that night. Now we go on to the erection of the cylindrical steel shaft itself. The slide shows the process at the 60-foot level. The cylinder is of high tensile steel, hot-dipped galvanized, made in 90-degree sections to a 9-foot diameter. Each section is 10 feet high with a 3-inch flange all round. Assembly is by through bolting flange to flange with a waterproofing mastic between the flanges. The wall is 3/8 of an inch thick at the bottom, tapering to a 1/4 inch thickness at the highest 650-foot level. 2 sections are bolted together on the ground. The assembled 180-degree sections are hoisted to the working level by a patent climbing derrick device. The climbing derrick consists of a telescopic boom supported at the bottom on a disc deck 20 feet below the working level, and at its midpoint by the disc deck at the working level. Construction of the mast is by a 3-step sequence. 1. Assemble the top section at the working level. 2. Raise the bottom support deck 10 feet to the joint above. 3. Raise the top deck to the top of the level just assembled. Then repeat the process up to the required height, 650 feet in our case. This shows the climbing derrick doing its stuff at the 130-foot level. The nice view of the old mast in the background. These 2 slides, with acknowledgement to BICC Publicity Department, show the work of the top rigger. Taken from the old mast, this one shows the hoist in mid-air to the left of the mast, with the rigger on the top deck waiting to receive it. 5 minutes later, the hoist has been hauled up by the rig on the climbing derrick to the rigger's hand. He secures it by spiking his podger, a marlin spike with an open-ended spanner on the other end, into one of the bolt holes on the hoist and through into the corresponding bolt hole on the mast. He and his colleagues on the deck then quickly insert all the many bolts, tighten them up and raise the derrick to the top to receive the next hoist. You'll notice some of the collapsing pit heads in the background on this shot. And here is the tubular part of the mast complete at 650 feet. The remainder of the mast is of conventional lattice construction based on round steel legs with scissor bracing to a triangular plan form. The lattice is of 6-foot side up to the 850-foot level and 4-foot 6-inch side up to 1015 feet. The slide shows the detail of the transition section between the cylindrical and lattice modes of construction. The porthole will be closed by a hinged steel disc opening into the inside of the mast. The outside of the disc will have a shelf on which a red aircraft obstruction light will be mounted, 1 of the 24 on the mast, 3 at each of the 8 light levels. And here is the mast topped out at the 1015 foot height. The lattice structure is complete and awaits the installation of the glass fibre weather shielding which is necessary to protect the aerials. And this shows the weather shield sections ready for installation. This shows the weather shield almost complete, with just a little of the VHF shielding remaining to be installed. And a more general shot of the site taken a few days later, in late October 1965. It shows the old tower, a bit ghostly, also the new GPO tower as it was, under construction in the background. And here is a slide taken a few years later. In the interval, the VHF black and white services were moved to the new mast. The old tower was dismantled and removed in 1966. A new building was built for the BBC, and they commenced colour transmissions on BBC Two in 1966. Meanwhile, a new colour control room was built in the ITV building, and a new ITV UHF transmitter hall was built. All was completed in 1968-69, and colour transmissions commenced from the site on BBC One and ITV in 1969. The new transmitters are much more stable and much more reliable and designed for unattended operation. The old 405 line black and white service continued for 15 years after the introduction of the colour service, and was finally shut down on the 5th of January 1985. And this slide shows the historic moment, the old black and white transmitters being switched off by the late Sid Catterall. Sid was on duty at Winterhill the day the station opened, 5th of May 1956, so he was given the honour of switching it off. And here now are the ITV UHF transmitters. Actually the second set, installed in 1988 to cope better with modern signals, including stereo sound and teletext and vision. The picture shows three of our engineers, Steve Mace by the transmitter, and in the background Mike Ingram on the left and Bob Dunbar on the right. And here are the Channel 4 transmitters, installed in 1982, and note the similar layout and essentially the same safety switch arrangements. Coming more up to date, the Channel 5 transmitters, installed in 1997, much smaller, all solid state, and only 4 kilowatts, but they achieve almost the same coverage as the bigger sets, a tribute to the better sensitivity of modern receivers perhaps. The two-channel combining room. Here the outputs of the ITV and Channel 4 transmitters are combined onto 2 large coaxial feeders so that they can be fed up to the aerials. And you see the 2 large feeders passing out through the wall at this point. And going outside to the mast bays, our feeders come down from the building on the right under a sheet metal cover to protect them from falling ice. They then bend upwards into the mast bays and up to the aerials. The BBC feeders come in from the BBC building on the left, carrying the BBC One and BBC Two programmes. And here is a bit of a view inside the mast. Not much to see except the ladder. The feeders are on the right, out of the picture. So, what does the feeder meet when it gets to the top? First, a 4-way splitter, one of which you see on the bottom of the display board. From each output on the splitter, a fairly thick coax, as shown hanging on the board, goes to a 6-way power divider. From each output of the power divider, the smaller cable connects it to a socket on the rear of an aerial panel. Here the engineer, Andy Smith actually, is demonstrating the aerial panel. And this view of the aerial panel shows the radiator slots. The slots are vertical at Winterhill to produce a horizontally polarized signal. There are 48 of these panels in the aerial. There's no room to take pictures up in the aerial space, so we have to resort to sketches. At the top right, you see the panels as they are attached to the mast. Top left is the plan view, 6 panels arranged around the mast. The outer circle, actually the GRP weather shield, could almost represent the horizontal radiation pattern. It is uniform within about 10% in all directions. On the lower right, we have the vertical radiation patterns. First, the rather dumpy lobe shows the pattern possible with one tier of panels. To get the required gain, we stack 8 tiers vertically to get the narrower pattern at the bottom with about 3 degrees vertical beam width. Now keep your eyes on the bottom sketch. Now we put the ground under it, and it makes more sense. The narrow beam is tilted downwards at an angle of about 1.5 degrees to center it on the horizon and give maximum distant coverage. The lower sketch is accurate but too flat to see detail, so we expand the height by a factor of 10 in the upper sketch and we can see what it's all about. This is the topographic profile towards Liverpool. The main beam hits the ground at about the distance of Wigan and continues at good strength over the Knowsley Plain and over Liverpool. Note the 2 cathedrals, then over the Mersey, the Wirral Peninsula and the Dee estuary, and just reaching the North Wales coast at its receivable limit. Closer to Winterhill, before the main beam touches ground, service is by side lobe radiation. The nulls between the side lobes are filled by carefully adjusting the phase of the feeds to the aerial panels, a test of the aerial designer's art and very necessary to provide a service in the nearby areas of Horwich and northern parts of Bolton. Looking to the right of Winterhill, we're on a profile toward the town of Darwin. Darwin lies at the bottom of the valley, screened from Winterhill, though only 5 miles away. So we put a mast on the hill beyond Darwin, pick up the base signal there, transpose it to a different channel to avoid interference, amplify it to receivable strength, and retransmit it down into the town of Darwin. This situation occurs at many locations, and we have about 76 such relay stations in the area. The yellow button shows Darwin just northeast of Winterhill, and several other relay stations and radio stations. Taking a more general view, the heavy red line indicates roughly the division of services between the regions of Lancashire and Yorkshire. Winterhill is at the red star. Over to the right, Emley Moor at the blue star is the main transmitter for the Yorkshire region and is also the control and monitoring station for all UK ITV stations, including many relay stations. The big yellow button between Winterhill and Emley Moor is the old BBC regional medium wave station at Moorside Edge, still going strong. The big red button is BBC Home Moss, formerly the source of all TV in the north of England in Band 1 in the black and white days, now a main source of VHF radio transmissions in the north. Returning to Winterhill, we have VHF radio transmitters for the ILR stations Rock, Smooth and Century FM. The BBC have VHF transmitters for BBC's Radio 2, 3 and 4 and Radio Lancashire. The slide shows some of these aerials are about the 240 foot level on the mast. Transmitter maintenance is by repair on site or module replacement. Modules can be repaired in the test room. Here, safety is a major preoccupation. Each test bench has its own power supply fed through its own safety circuit breaker, and adequate sockets for any tasks on the bench. The benches are designed and orientated to prevent accidental electrical contact between engineers on adjacent benches. There is Alan Powell and Andy Smith. On the other side of the test room we have Ian Campbell nearest, Graham Sanderson behind. Note the red safety buttons on each bench again. Also on the wall by the door is another red button. In case of emergency you can hit this button as you come in and make all the benches dead. Getting outside now, the mast itself requires a great deal of maintenance. Mast verticality and stay tensions are checked regularly. Stays are greased every few years and the mast is painted in a similar cycle. The mast must be vertical within 1 inch in still air conditions. Stay tensions must remain within close limits of their design value, any variations requiring thorough investigation. This slide shows the cage, which can take 4 men up to any required height. It's much easier than climbing the ladder. Here we see the stay tensioning in progress. The 3 great riggers, Jim Docherty waving from the top, Benny Gilroy on the ladder behind him, and Jim's brother Charlie Docherty concentrating on the pressure gauge, which indicates the tension in the stay. This operation must be done in a wind speed not exceeding 4 miles per hour to get valid results, so it's a nice job for a nice day. And here it's not such a nice day. A winter day with some icing on the stays, which you can see in the picture. In freezing rain conditions the ice can accumulate very quickly up to about 10 inches thick. It can be very heavy and it would be lethal if it fell on you during the thaw. So you wear a hard hat and keep vehicles under cover to avoid damage while the ice is falling. Here we have a winter snow scene with the hill living up to its name. Notice the snow posts and the deep drainage ditches either side of the road. In winter the weather on the hill can change from a pleasant winter walk to a whiteout blizzard in about 10 minutes. When a Bristol wayfarer from the Isle of Man crashed on the hill in February 1958, killing 35 people, the road had been impassable for 2 days. Staff were walking into work. The crash occurred at 09:45 in the morning, and it was after 2 p.m. before ambulances could reach the site. This plaque on the Channel 4 building commemorates the disaster. And here it's a much better day. The 100-foot platform's always a good spot for photography. And here is one view from the platform. The Victoria Tower above Darwin on the left, the BT Telecoms Tower, and then Pendle Hill 20 miles away on the right. On a very clear day you can see the top of the Isle of Man 85 miles away. Now, getting up to date, we have 2 satellite dishes which can bring in programs from either of 2 link satellites. And so we go on to digital terrestrial television. Here 1 multiplex or MUX, which can transmit up to 8 TV programs. This is due to the magic of MPEG-2 digital coding, which takes advantage of the redundancy due to static parts of the picture, while preserving moving details such as the flight of a tennis ball. Then, using quadrature amplitude modulation, it can put 8 programs on 1 RF TV channel, allowing your set-top box to extract the program you want. In addition, a digital system can tolerate much more noise than an analog system, so transmitter power can be much less. This MUX in the picture transmits only about 4 kilowatts to put out 8 programs. And here is a view of the digital MUX monitor, showing the picture clear on the left and overlaid by the program menu on the right. This shows one of the first digital service aerials, right on the top of the mast. It carried much of the digital service from its commencement in December 1998 until the fall of 2008. Here is the overall aerial arrangement as it was for some years until early in 2007. This gave 4 analog programs at 500 kilowatts and Channel 5 at about 20 kilowatts. By the fall of 2008, this was replaced by wideband aerials capable of handling 6 multiplexes or muxes, as well as the analog channels. Each mux will be transmitted at about 100 kilowatts in the final arrangement, and each will be capable of handling 8 digital terrestrial TV programs. The work program on the aerials had to take due account of the following problems. 1. The aerial season at Winterhill is confined to the beginning of April to about the end of August. 2. Present TV programs could not be interrupted due to the work. And 3. Installation procedures must not expose the aerial installers to out-of-limits radiation hazards. A new state-of-the-art broadband aerial was installed in the lower aerial space, capable of handling all the digital TV channels at full power. The aerial consists of 12 tiers of 12 panels in a wrap-round arrangement around the mast, with a radiation pattern similar to that of the original UHF aerials. This phase was completed in the fall of 2007. The next 3 slides are with acknowledgement to Carl Boardman at Winterhill. The new aerial is constructed as 4 semi-cylindrical sections, each carrying 6 tiers of 6 panels. This section is about to commence its upward journey. And here we are in mid-air, and it is nearly there. You can just make out the 3 riggers waiting to receive it. And here we have the completed or commercial aerial ready for service by the fall of 2007. Moving on to the fall of 2008, the second broadband aerial, the PSB aerial or Public Service Broadcasting aerial, has been installed in the upper aerial space and the PSB programs transferred to it. The cantilever structure has been removed from the top of the mast. Analog TV will continue from the new aerials as well as digital TV until switchover day. Much groundwork and testing will continue into and through 2009, including the installation and commissioning of new and more powerful digital transmitters. These, together with the relay stations, will give good digital coverage of the whole Granada service area. 5 of the muxes will between them transmit all the present standard definition TV programs. The 6th mux will transmit up to 4 high-definition programs in the 720 line HD standard. Viewers with HD-ready TV sets will be able to receive these programs via new set-top boxes, which will be available toward the end of 2009. On switchover day in November 2009, the analog transmitters will be switched off, and the new aerials will be switched over to the new high-powered digital transmitters. This will mark the end of the historical era of analog TV transmission, which commenced in this country in 1936. Meanwhile, many thanks to Alan Powell, the project engineer, also to Carl Boardman and the staff at Winterhill for their help and advice, and also to Trevor Birkbeck, Antenna Designs consultant, for taking the time to brief me about the new aerial setup. They are all very busy, and we wish them all good luck and good weather. But people have been busy already. We have new, upgraded and uprated mast lights conforming to the latest aeronautical regulations. These were switched on for the first time on the 17th of October 2006. And finally, a perspective view with the mast lights showing on the skyline, looking out over the busy town of Horwich. Bolton Wanderers Reebok Stadium there on the right. So we've had a look at the future, and we can close the show with a little reminder of the past. With less program hours, we sometimes radiated this test card and recorded music. The young lady is the daughter of a BBC engineer who was at Crystal Palace about 1970. Can anybody tell me her name? I hope you enjoyed the show.